Hello, my loyal followers, and welcome back to Jake of All Trades. Today's episode is going to be a little bit different from my other episodes, as you can probably tell. This is not about me going on some wacky job training experience in VR this time. This is about a project that I've been putting together in my personal time. If you've been following this channel, you're probably wondering why I am learning all of these trades and what exactly all of this is in service to. And the fact is, I am making my own VR game in Unity behind the scenes. I have my own projects going on, and this is one of them. This is my Gaussian Splat project. I took some Gaussian Splat captures in real life, and I brought them over into Unity, and I can now hop into them in VR. Most of this project is based on another work. This one specifically, this project, the Unity VR Gaussian Splatting by Ninjamode, which itself is heavily based off of Unity Gaussian Splatting by Aras-P, which itself is based off of this 3D Gaussian splatting paper. I noticed there's a VR URP demo in Unity VR Gaussian splatting, but I could not get it to work. So if you are like me and have struggled to get this project to work, perhaps this video can help you. This is just my workflow, and to be quite honest, the main purpose of this video is really just for me in the future, looking back to try to see how I got this to work the first time. But if it helps other people, then the more the merrier. Let's share the knowledge with the world. Anyway, here's a quick little demo of how it works. This is a Gaussian splat that I took of the Toyota Center in Houston, Texas. And if we hop into VR real quick, I can show you a little bit where it's not obscured by all the Gaussian ellipses in the foreground. It's not really very impressive in a 2D screen recording, but I'll try to make it work as best I can. Okay, here we are, and we have a problem, but I can fix this super easily. The entire world is upside down, but we can fix this by simply rotating it 180 degrees. But unfortunately, that does have the side effect of flipping the entire thing horizontally. So we can fix that by just setting the z-scale to a -1. You're going to learn all of my tips and tricks on these Gaussian splats in this video. But anyway, here's the Toyota Center. We do look like a little bit of a giant right now. So let's increase the scale to 2. We need it to be 2 in every dimension. 2, 2, -2. And then the height of it needs to be, let's say about 1.75. There we go. That's a bit of a more realistic Toyota Center. I'm sitting in my chair right now, so if it looks like the barricades are coming up to eye level, then they're the perfect height. Oh, whoops. I fell off my platform. As you can see, I have this cube right here, which I've flattened to make a small little platform I can walk around in. But anyway, that's the gist of it. That's how it works. And in this video, we'll start from complete scratch, a completely new project, and get everything set up. Please excuse the mess. But this is the project I'm working in, just creatively named my project for right now. And then we'll make another one in the exact same Unity editor version. I'm using 6000.2. That's me. We'll do my project too. And then I'll do this project without version control since this is just for demonstration. We'll start with the VR demo scene. That's just to get the basic VR scene up and running as quickly as possible. Alright, there we go. I do want to very quickly note two very important things about this project before we move on to our new project, which is that this works in VR, and it works for both eyes. Sometimes if you're trying to get the Gaussian Splat project to work in VR, then it'll only work in one eye or give you other sorts of weird errors like that when it tries to hook into the rendering pipeline. But I know you can't see it on the preview camera, but it does work in both eyes for me. The second thing to note is this is all running locally on my desktop, and I have the good fortune to have a RTX 5080, so it's a pretty beefy GPU for current year. But if you have a less powerful GPU, or like me, you eventually want to run this standalone on your headset, I'm using a Quest 3, then you may need to wait for my follow-up video. I am going to attempt to get these Gaussian splats to run more optimized to the point where I can eventually run them on standalone on my Quest 3, but to be totally honest, I don't have the capability of doing that just yet. But if you just want to run it on a desktop with a powerful GPU, then you're in luck. This tutorial is still for you. Alright, still on board. We'll go to the new project. Okay, so we start off with our virtual reality template, and we mostly do that to get this all-important XR Origin Hands camera rig. Let's take all the interactables and UI and the environment out of here. We'll drop in a new game object, a cube. I prefer cubes to planes personally because it's more difficult for objects to glitch through them. For some reason in Unity, the planes don't really like to hold objects on top of them. So we'll put this at -0.5. Alright, so now we have a plane to walk around on. So let's go grab the GitHub files from Ninjamode. I already have a couple of these downloaded, which is why it's got this 2 in parentheses right here. But that's beside the point. We're doing this from scratch, every step from scratch. Alright, now that we have that, we will just import it into this project, and after that, we can really get rocking and rolling. You're also probably going to need the latest version of XR Interaction Toolkit and XR Plugin Management, so we'll grab those while we're here. Alright, let's make sure all of our project settings are correct. We will probably be back here many times in the future to make sure that every setting we have is exactly the way we want it to be in order for this to work. Let's see, OpenXR, yes. OpenXR, initialize XR on startup. XR simulation is unchecked, that's good. HMD is unchecked, that's good. You see. Okay. So here in the graphics API, it says Vulkan for Android and Meta. I also like to go to my Windows graphics API and then just also change that to Vulkan if I can. Where did I see that? Alright, so that's just so we're using the same graphics API on both systems. We'll save this and then switch out the rendering pipeline to the other one, to Vulkan. There we go. Now the main script here that we're going to be using is the called Gaussian Splat Renderer. But as you will see very quickly, there are going to be a few problems with using Gaussian Splat Renderer. First, let's create a Gaussian Splat asset by going to Tools, Gaussian Splat, create Gaussian Splat asset. Okay, I got my Toyota Center, Gaussian Splat scan, and here you can specify the quality of the scan. Setting this to very low or custom is one of my ideas on how I'm going to optimize this to work on standalone headset. But you don't need to import cameras, that's totally optional. Anyway, once we created our asset, we'll go back to our game object with the Gaussian Splat renderer on it, and then choose that asset. So as you can sort of see here, there's something wrong because the asset is not rendering in the preview window. But we will see if we can correct that. We'll get rid of this error right here. That was just telling us our game object didn't have a splat asset in it yet. Anyway, go to Assets, Settings, Project Configuration, and then for the Quest 3, we would go to Android Presets, and then Add Renderer Feature. So this is the original Gaussian Splat ERP feature from the original GitHub, and as you can see, nothing really happens. So we're going to remove this temporarily, and then we're going to go into the package, Gaussian Splatting package, go into Runtime, and we're going to get rid of Gaussian Splat Renderer script. And we're going to get rid of the ERP feature script. And we're going to replace them with the these two scripts from my project, which will be up on GitHub, and I'll link that in the description. Oh, we do not want to open that, we want to do that. Okay, there we go. Copy. And paste. Simple as that. Just drop these two in there. And now what we got to do is we got to replace our references to those scripts in the scene. I'll just remove and throw this component back in there just for fun. We can keep our old Gaussian Splat asset that doesn't have to change, and then we'll go back to Assets, Settings, Project Configuration, Preset, and then add the ERP feature. As you can see, it doesn't recognize the script as the ERP feature just yet. It takes a little bit of time for a Unity to recognize that there's a new universal render pipeline feature, and to be able to add it to this list. Alright, let's see. After importing those scripts, you may get these errors. It has some beef with radix sort, apparently. To be honest, I forgot how I solved this problem the first time. That's what this video is for. So if I ever forget again, I can just look back and see how I solved it. Let's see. Did I even use radix sort? Yes. So I must have overcome it somehow. Ah, okay. That's our problem. Our shader resources are not set up. Let's see what those are supposed to be. Alright, Gaussian splatting, render splats. Yep, okay, here we go. We have to set up all of these resources. And they're not going to make it easy for us. So we will just have to do it the hard way. Render splats. Composite. Render points, debug boxes. There's radix. There's fidelity. All right. Now we shouldn't get those errors anymore. We have our center. We have our Gaussian splat. And now let's see if we can add our URP feature yet. Still no. Okay. Let's just take this conditional out just for fun. All right, cool. Let's see. What does this look like in VR? Absolutely nothing. Also, what is this thing? But you don't need teleport. I don't use teleport personally. Well, we appear to be missing something. Let me see if I can figure out what that something is. Maybe I did not add the right script. Okay, here we go. This script depends on compatibility mode, so we'll have to enable that. Eventually, I will have to use render graph API instead of compatibility mode, but that's a video for another time. There we go. There's our beautiful Gaussian splat. It looks like it is not rendering correctly. You can only see it on top of the plane that I rendered earlier. I bet that was because of one of the settings that I played around with earlier. Specifically this one. Let's see. What was it on before? Before transparency. There we go. There it is in all its glory. And for the cherry on top, we'll just change these values in the transform to what I had originally. And now the moment of truth, to see if it works in VR. You, the audience, won't see, but I will. So you'll have to take my word for it. It works. It's just upside down for some reason. I know the perfect reason why. It's because I forgot to change this to 180. And it works in beautiful stereoscopic vision. Both eyes work correctly, but you'll have to see it for yourself to know that. Now you may notice some parts of the Gaussian splat do look a little bit choppy. The software I was using to capture these splats does not work so well on repeating uniform patterns such as these tiles on the floor, which is why you see it exploding a little bit over here. But other than that, it does have pretty good fidelity on unique 3D objects like this. So hopefully as Gaussian splatting capture technology improves, we get better and better quality Gaussian splats to play around with in VR. But as for right now, it does look shockingly realistic in some parts. Shockingly. And the rest of it sort of has this hazy, artistic paintbrush or dreamlike quality to it, which I like very much for my application of it. It's you're supposed to view it as though you're going through memories. I have good memories of the Toyota Center. But anyway, that's all for my tutorial right now on how to set up and use the Gaussian splats in URP. And I will say a quick word about the Gaussian splat software I was using at the end of this. But after that, you're on your own. So here's the software I was using. I have an Android phone, so it doesn't have a LiDAR scanner in it like some of the Pro lines of iPhone, starting with the iPhone 12 Pro. I found that Curie Engine works the best out of any app for Gaussian splats from iPhone. The Gaussian splat capture on Curie Engine is on the paid tier, but it doesn't cost very much. I think it's like $20 a month or something like that. But they do have year-long pricing subscriptions available. And every Gaussian splat you take, you have the option of opting in to send your data to help train the AI, or not opting in, which is very nice that they give you the option to maintain your data. And the fact that you do have the option to help send in your splats to help the AI learn and develop gives me some hope for the future that maybe this will be an even better 3D scanner in the future. I'm not sponsored by Curie Engine. I have like 2 subscribers, so it wouldn't make a whole lot of sense. But this is just my personal opinion on the best Curie engine for Android phones. However, if you do have an iPhone Pro with the LiDAR scanner in it, I also recommend Scaniverse from Niantic, the same people who made Pokemon Go. But this is slightly better than the Curie engine. The only reason I didn't use Scaniverse is I didn't feel like buying an iPhone just for a slight improvement in quality for the Gaussian Splats. But anyway, that's my little tutorial for how to get the URP working for Gaussian Splats. And I hope you enjoyed, and I hope this has value to you. I will link the new scripts for the URP feature and the Gaussian Splat renderer. See you next time.